Today, most modern graphical user interfaces are implemented using UI toolkits, which significantly accelerates the GUI design process. Unfortunately, as designers use a wide variety of toolkits and libraries for UI creation, it is generally challenging to modify or customize an existing UI layout, especially if the source code or UI builder specification is not available. The diversity of UI toolkits makes it also challenging to add consistent new features or behaviors across a variety of applications, toolkits, and platforms. The problem of reconstructing and understanding an existing UI for further development is called UI reverse engineering. Previous user interface reverse engineering approaches detect widgets and their hierarchy based on accessibility toolkits, the pixels on the interface, or a mixture of both. No previous approach reverse engineers the dynamic resized behaviors of a UI layout. We propose ReverseORC, a novel reverse engineering approach able to discover diverse layout types and their dynamic resizing behaviors independently of their implementation. ReverseORC samples multiple sizes of the user interface to detect changes of the layout and then synthesizes a new layout specification based on the results. A designer may want to modernize a legacy layout to benefit from novel platforms and technologies. However, it is common that suitable source code is not available or hard to understand and adapt. For example, if a designer wants to design a toolbar with similar structure and layout behaviors as the Microsoft Word ribbon toolbar, it may not be possible to reuse the original source code. Instead of creating a new toolbar from scratch and manually add all the functionality of the original one, our ReverseORC prototype is able to reverse engineer GUI layout specifications based on the GUI's resized behaviors and generates a reconstructed GUI nearly identical to the original one. ReverseORC first extracts widget information from the UI through accessibility APIs. Then it uses a GUI search to sample and resize the layout through setting different window or screen sizes. ReverseORC keeps track of the differences between neighboring layouts during the sampling process. In this specific example, as the height of the toolbar is fixed, starting from the minimum and maximum width of the layout, we keep subsampling layouts using the middle width of the existing samples. After the sampling process, we have a comprehensive set of layout exemplars and information about the transition positions between neighboring layouts. We reconstruct layout structure by dividing layouts into rows and columns. This structure preserves common widget alignments and makes it easier to compare layouts and detect the differences between them. We traverse the resulting layout structure and create a corresponding specification tree. Each widget becomes a leaf node, while each row and column becomes an internal node. Given layout specifications as input, our novel tree difference detection algorithm generates a set of edit operations that indicates the differences between two layouts and can be used to further infer layout behaviors. Based on the layout differences, ReverseORC then infers overall layout behaviors and reconstructs the corresponding orc layout specification, enabling later modification and customization. ReverseORC can be used on dynamic hand-coded GUI layouts. Here we present our reverse engineering results for the Microsoft Word ribbon. We visualize the overall quality of reconstruction at different sizes by color-coding structure error in yellow, transition error in blue and green, and fault lines in black, indicating possible inconsistent behaviors. Based on the positions of fault lines, designers can modify org layout specifications to remove inconsistent behaviors and improve the layout. For example, in this case, groups of widgets change their positions in a way that may be confusing to the user. We correct this by changing the alternative position pattern that was constructed to a horizontal flow pattern, which is more predictable. ReverseORC enables porting of layouts across platforms. For example, designers may want to replicate a web layout in a mobile app, or vice versa. Here we take the BBC News website as an example to show that ReverseORC can reverse engineer web layouts to GUIs. Here is the result of reverse engineering the BBC News website for a desktop GUI environment. As ReverseORC is platform and framework independent, a layout can be reused in other applications. ReverseORC achieves this by unifying different types of layouts using org layout as a common specification language. As shown here, it enables designers to combine GUIs and web-style layouts in a single interface.